Why are moles so important for chemists? Well, imagine you're one yourself and you work in a chemical plant. One of your customers has ordered 100 kilograms of copper sulfate crystals. To deliver this, you need to dissolve copper oxide in hot sulfuric acid. This will produce copper sulfate solution from which we can get the blue hydrated copper sulfate crystals that you might be familiar with. Here's the problem though. How do you know what mass of copper oxide to place in your tub of acid? If you use too much, not all of the reactant will dissolve and you'll have to spend time and effort separating the undissolved solid from the solution. Too little, and you simply won't produce enough product for your customer and fall behind schedule. Either way, you could be in trouble. But with the help of moles and a simple equation, problems like this can be easily solved. The first thing to do with any challenge like this is to look at the chemical equation and balance it. Fortunately, that's not difficult here because, as you can see, all we need to do is change the molar ratio of the water from 1 to 4. The molar ratios for all the other species are 1. You now know that every 1 mole of copper oxide reacts to form 1 mole of copper sulfate. 100 kilograms or 100,000 grams of the copper sulfate are required. We need to know how many moles of the product this represents, and here's where the equation comes in. The number of moles needed equals the desired mass, 100,000 grams, divided by the relative molecular mass of the product we want, copper sulfate. Using your periodic table, you can work out that this is 63.5 for the copper atom, plus 32 for the sulfur, 9 times 16 for the oxygens, and 10 times 1 for the hydrogens, altogether making